Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video we are going to discuss about Dalton's Law, a question that relate to the Dalton's Law with a balanced stoichiometry coefficient. Alright, so the concept of limiting reactant also involved here. So let's read the question together. A combustion of ammonia in excess oxygen produce a nitrogen monoxide and water vapor, writes a balanced chemical equation. Okay, so the reaction is between the ammonia and the oxygen produce nitrogen monoxide, which is a gas, and a water vapor is also a gas. First we need to write a balanced chemical equation. Okay, so the reactant and the product is already given. So maybe we can write the equation first. So this is the answer for A. We have an ammonia in a gaseous phase react with oxygen producing nitrogen monoxide, which is NO, and water vapor. So how to balance this equation? Let's say I put 2 here and I will have 2 here. 2 times 3, 6, 3 here. So in total I have 3 plus 2, 5 mole of oxygen. So 5/2. If I want to make it a whole number, so I will multiply by 2 for the whole equation, so that it will become 4 mole of ammonia plus 5 mole of oxygen produce 4 mole of nitrogen monoxide produce 6 mole of water vapor. So this is the answer for A, and the equation is balanced. So now let's look at the B. Let's look at B. Okay. In an experiment conducted at 100 degrees Celsius, so the temperature is given, 2 mole of ammonia was combusted with 6 mole of oxygen in 5-liter container. Determine the number of mole each product. So if you can see, once the reaction happen, we have a mixture of gas. Once you have a mixture of gas, meaning that we need to apply the Dalton's Law. So in my lecture, I already discussed about the types of Dalton's Law. So this case, it is referred to the first stage of the Dalton's Law, where all the reaction occurs in one tank. Alright, so we have 2 mole and 6 mole of oxygen. So now we can put the information below the equation. So I will rewrite the equation again, because I want to start with the calculation. Okay, so here we have 2 mole and here we have 6 mole. This is the initial number of mole. So as I said previously, if we have a balanced chemical equation, we have the number of mole or any information for the both reactant, we need to determine the limiting reactant. It is a compulsory. Alright, so to determine the limiting reactant, this is the new stage. Even though it is not asked in the question, it is it is a compulsory for you all. So 4 mole of ammonia equivalent to 5 mole of oxygen. If we have 2 mole of ammonia, meaning that we have 5/4 times 2 mole of, so you will get 2.5 mole. If we can see, this is the number of mole needed and this is the number of mole available, meaning that ammonia is your excess reactant. So you can write mole ammonia available is greater than mole ammonia needed. Therefore, not ammonia. I'm not talking about ammonia. Mole oxygen actually. Mole oxygen available is greater than mole oxygen needed. Therefore, oxygen is an excess reactant, but ammonia is a limiting reactant. So this is the important thing. Okay. So if we can illustrate the process, let's say we have one tank. At the beginning of the reaction, we have ammonia and oxygen. Once the reaction occurs, it will produce nitrogen monoxide and water vapor. Because ammonia is a limiting reactant, at the end of the reaction, there is no ammonia. How to determine the number of mole nitrogen monoxide and water vapor produced? The tank is 5 liter. Okay. And the temperature is 100 degrees Celsius. Okay, for the reaction. Right now, once you have the number of mole, now we want to determine the number of mole nitrogen monoxide. So we still have to refer to stoichiometry. For mole of ammonia, our comparison with ammonia, because ammonia is a limiting reactant. 4 mole nitrogen monoxide. If we have 2 mole of ammonia, meaning that we have also 2 mole nitrogen monoxide. So we can draw here. So for nitrogen monoxide, the amount that we have is 2 mole. How many mole of water vapor form or produce? So that we have to write another comparison. Okay, 4 mole, 6 mole. This is for water vapor. 4 mole of ammonia equivalent to 6 mole of water vapor. If we have 2 mole of ammonia, meaning that so water vapor 3 mole. How many mole of oxygen in a tank left over? So for the oxygen, so we can write like this. Initially, mole initial minus mole being used, you can get the value. The initial number of mole oxygen given is 6 mole, and the number of mole oxygen used is based on this comparison, which is 2.5 mole. Which is 2.5 mole. So minus 2.5 mole, so become 3.5 mole. So for oxygen, 3.5 mole. So what is the total number of mole in a tank now? It is the sum of mole oxygen, mole NO, and nitrogen monoxide, and mole water. So let's read the question together. After we determine all the number of mole, determine the number of mole of each product formed. So we already determined. So this is the answer for nitrogen monoxide. This is the answer for water vapor. N, this is the answer for, no, this is for oxygen. Yes, oxygen left. So the next question, we need to determine what would be the total pressure in a tank. Okay. What would be the total pressure? So, based on this diagram, okay. Based on this diagram, we know that the pressure in a tank is the total pressure according to the Dalton's law equal to partial pressure of oxygen, partial pressure nitrogen monoxide plus partial pressure of water vapor. So we can expand the formula. P is equal to N oxygen RT over V plus P nitrogen monoxide RT over V plus P water vapor RT over V. We also can combine NO2 plus, sorry, not P, plus NO plus NH2O RT over V. What is N? N is 3.5 plus 2 plus 3 R 0.08206 T. T must be in Kelvin because it's involved the value of R. So 100 become 373.15 and the volume is 5 liter. And what is your total pressure? Yes, 52.05 atm. And what is the partial pressure of each gas? So we have two formulas. We can use the mole fraction or you can calculate PV is equal to nRT for each gas. So let's say I want to use a mole fraction. So for the oxygen, P oxygen, for example, mole fraction oxygen times P total. The mole fraction of oxygen is 2.5 mole over the total number, sorry, not 2.5, 3.5. The total number of mole is 8.5 times 52.05 atm. It is 21.43 atm. And then partial pressure for maybe for nitrogen monoxide is mole fraction nitrogen monoxide times P total, which is the mole fraction is 2 over 8.5 times 52.05. .25 atm. And the last one is P water vapor is equal to mole fraction water vapor times P total, which is 3 over 8.5 times 52.05 atm. .37 atm. Okay.